Alright, this video for 3HT about exercise 60 from chapter 7. It's still about a three-dimensional shape. You have to calculate some angles. So for the first exercise, you see that I already drew something in the picture. We need to calculate angle CEF. So that means the E is the angle that we actually need to calculate. That's that one. And from C to E to F means from C to E to F like that. Yeah. So that means that we need to use this triangle to figure out what we need to do. So because this picture looks a bit, weird, so 3D like that, I made a beginning of a sketch over here. And then C is over here, E is over there, and F is over there. And the angle that we want to know is that one. So if we know two of these lengths, then we can use either the tangent, the sine, or the cosine. If you take a look in the picture, we know EF, because EF is 8. So that's nice. And we don't know one of the other ones. So you have to pick one and then calculate it. It doesn't matter which one you pick. I'm going to pick this one, CF. So if I want to calculate CF, then I have to do the square root of, this length is 6, and this length is 5. So 6 squared plus 5 squared. Now 6 squared is 36, 5 squared is 25, so this is the square root of, when you add this, you're going to get 61, the square root of 61. Now you can just use that in your calculator. You don't have to calculate what that is. And then we're going to calculate angle CEF. We know this side now, and we know that side. So we know the opposite side and the adjacent side. So I do 10 minus 1, and then we do the opposite side, which is the square root of 61, divided by the adjacent side, which is 8. Now you can type that into your calculator, and then you get 44.3 degrees. Alright, now let me do one more. I'm not going to do them all. We'll just do the last one, because that's probably the most difficult one. That's DPC. So you need to go from D to P to C. So that's that one. Yes. So let me make a sketch of that situation. So here we have DC like that, and then we have a line going like that, and then a line going like that. But I don't know if the angle is 90 degrees though. I think we need to take a look at that, because we do know that this length is 8 here. That's at the bottom. It's 8, and we don't know the length from D to P, and we don't know the length from C to P. And I also don't know if the angle is going to be 90 degrees. But one thing that we do know is that this length here is 3. See that? That's 3. And this length, if you go from the bottom to the top, is 5. Okay, so what we have to do here is we have to make an additional line here, like that. And the additional line is 5. And we know that this is 3, and we know that this is also 5. And the reason that we know that is because it says so over here. If this is 3, then this is 5, right? And this is actually, this triangle is actually part of the rectangle that you see at the back. At the back you have rectangle DCGH, right? And that's actually this one also. And the angle is over here. So we need to calculate it in two parts. We need to calculate this angle and that angle and then add it. So the first part is the tangent minus 1, and then the opposite side, 3 divided by 5, and the other thing is the tangent minus 1, and then 5 divided by 5. So if you add that, then you get angle DPC. So this is how you calculate that, and if you want to know it, it is 76.0 degrees, and this is how you calculate angle DPC. Now, I do see that in the book they did something completely different, but this is the easiest way, I think. All right. So thank you for watching. You can do B and C yourself, and then see if you have it correct. I'll see you later. Bye bye.